All right, you are welcome again. Today, let's take a look at this interesting question. We are asked to differentiate from first principle y is equal to sine squared 4x. Yes, we've been talking about derivative differentiation, but today let's talk about derivative or differentiation using the first principle or differentiation or derivative by definition. By what? By definition. Is either you call it differentiation by definition or using first principle, whichever one, both of them are same. So in this question we are asked to find the derivative of y is equal to sine squared 4x, not using the normal method everyone knows, but using the first principle. Okay, now look at my own approach. The way we're going to solve this, we're going to make it as simple as possible. So you only need to remember just few things, and if you can remember these few things, you are good to go. Okay, now by definition of derivative, here we have f prime of x is the limit as change in x approaches 0, f of x plus change in x minus f of x all over change in x. So this is what we mean by differentiation or derivative. This is the definition, the mathematical definition of what? Of derivative. So when they say derivative using the first principle, this is what they are talking about. Or derivative by definition, this is what they are talking about. So we are going to use this method to find the derivative of y is equal to sine squared 4x. All right, please, let's do this carefully. Now let's go. From this definition where we have f prime of x is equal to limit as change in x approaches 0, f of x plus change in x minus f of x all over change in x. What is our f of x? F of x is the y that we have, okay? And then f of x is sine squared 4x. Good. Now the next one is, what is f of x plus change in x? F of x plus change in x. That is, we just finished f of x. Now it's no longer f of x, but f of x plus change in x. That is, in the place of x, anywhere we see x, we are going to write x plus change in x. Are we together? So we have a function that is for this x plus change in x, okay? And we also have our real function or the original function, which is f of x. So here now, what we have sine squared 4x. So in the place of x now, we are going to have x plus change in x. Okay, good. Now look at it. We have figured out the things we need. F of x, we have it. Then f of x plus change in x, we have it. Now let's bring it into this equation 1, which is the definition. Okay, good. That means we have f prime of x is equal to limit as change in x approaches 0. In place of f of x plus change in x, we have sine squared 4x plus 4 change in x. I'm very sure you understand this, right? Good. Then minus, what is f of x that we have? It is sine squared 4x. Then all over change in x. Let's call this equation 2, please. Okay, good. Now look at this. When you hear something like sine squared x, I want you to know that it is the same as saying sine x multiplied by sin x. Hello, is that not? Yes, it's true. When you say sin squared x, it's the same as saying sin x multiplied by sin x. And if you have sin cube x, it's the same as saying sin x multiplied by sin x multiplied by sin x. Yes, it's the same. So if it is the same, it's also the same as saying sin x all in bracket squared. Hello. Yes, it's the same. So you can put the squared inside or everything squared is the same. So if it is the same, in this numerator where we have sin squared 4x plus 4 change in x, we can put everything, both the sin and 4x plus change in x, we're going to put it in a bracket raised to the power of 2, and then sin squared 4x everything raised to the power of 2 also. So let's do it. We are going to have f prime of x is equal to limit as change in x approaches 0. Here we have sin 4x plus 4 change in x in bracket all in bracket raised to the power of 2 minus sin 4x in bracket raised to the power of 2 all over change in x. Please, let's call this equation 3. Okay, good. Let's go. Again, recall that there is something we call difference of 2 squared. Difference of what? 2 squared. What is it talking about? Where you have a squared minus b squared is difference of what? 2 squared is difference of squared. So when you have a squared minus b squared, it's the same thing as saying a minus b times a plus b. Why do we bring this? We want to convert the non-linearity that we have to linear. You see this power 2, we want to remove the power entirely so that it will be very easy for us to solve. So we are having squared whatsoever. We want to remove the power and make it to be what? Linear without power. Now let's go. That is our dream. So here we have sin 4x plus 4 change in x all in bracket squared minus sin 4x all in bracket squared. So we want to remove this squared and make it linear without losing our values. Okay, so you see here, you can see in this case now that a, or we can say that this sin 4x plus 4 change in x can stand as our a, and then sin 4x can stand as our what? Our b, so that we will have a squared minus b squared. A squared minus what? B squared. So a is what? Sin 4x plus 4 change in x, and then b is what? Sin 4x. Okay, so if we replace sin 4x plus 4 change in x with this letter a, and then sin 4x with the letter b, what are we going to have? Look at how the equation or the expression is going to look like. We are going to have f prime of x is equal to limit as change in x approaches 0. We are going to have a squared minus b squared all over change in x. Okay, now look at this. Here it's looking simple. I want you to understand what we are trying to do. You see here we have a squared and b squared. We want to remove the squared so that it will be simple linear. Okay, now for us to remove the squared without losing our values, we are going to have a minus b in bracket and then a plus b in bracket. It's still the same thing. You can still bring it back if you multiply it, but we want it to be like this so that it will be easy for us to solve. Okay, good. Now we have written it a minus b in bracket, a plus b in bracket. Remember that we declared a variable. We say that this a is equal to sin 4x plus 4 change in x, and that b is what? Sin 4x. So in this place we have a minus b in bracket, a plus b in bracket. Let's bring it back. Let's bring the value for a and b back. So when we bring it back, we're going to have f prime of x is equal to limit as change in x approaches 0. In this place we are having a minus b. A is sine 4x plus 4 change in x. Then minus b. B is sine 4x. And then you see that is in bracket. Then multiply by the next bracket. A plus b now. We have sine 4x plus 4 change in x plus b is sine 4x all over change in x. Yes. Are we together? Yes. So, when we started, I told you that you need to remember just few things. So one of those things you need to remember is this. You need to remember what we call sum to product rule. Sum to product rule. Look at it. In this numerator, we have two brackets. One is addition and the other one is subtraction. So we want to turn this addition and subtraction to multiplication. How can we do it? Now, in trigonometry, there is a formula called sum to product formula. What does it talk about? It said that when you have sine x plus sine y, you have sine x plus sine y. This is sum now. You can change it or you can turn it to product. How? It's going to give you 2 of sine, open bracket now, x plus y all over 2 multiplied by cos x minus y all over 2. Hello. Where we have sine x plus sine y. In addition, this is addition, right? So you can convert this addition to multiplication. That is to say that sine x plus sine y is the same as saying 2 sine x plus y all over 2 multiplied by a cos x minus y all over 2. Again, for the subtraction, this one is sum. For the difference now, which is subtraction, or you call it difference, sine x minus sine y is going to give you 2 sine x minus y all over 2 multiplied by cos x plus y all over 2. Yes, you need to remember these two formulas. It's very, very important and also easy to remember. Sine x plus sine y is equal to 2 sine. You have x plus y all over 2 multiplied by cos x minus y all over 2. Here we have 2 sine x plus y all over 2 cos x minus y all over 2. Cos in this side is having x minus y. So again, here we have sine, cos, and then for the difference, we also have sine and we also have cos. But the content of this bracket where we have x plus y all over 2, for sine, for the addition, sine is positive. For the difference, sine is negative. And then for addition, cos is negative. And then for difference, which is subtraction, cos is positive. I just want you to study it very well and then master the pattern. Just master the pattern, okay? Good. Now let's go. In this numerator, we have sine 4x plus 4 change in x minus sine 4x. Here we have sine, but sine of what in the first part is different from the second part. So the first part we can actually call it x, and then the second part we call it what? Y. Are we together? So here we have sine 4x plus 4 change in x, and this 4x plus 4 change in x is the same thing. Okay, so we call this 4x plus 4 change in x a letter. We call it x. And then 4x, here we have sine 4x. So this sine 4x now, 4x is going to be our what? Our y, so that it will correspond with this formula we are bringing from trigonometry. Are we together? I don't know if you understand this. It's very simple, please. Good. Now look at it. In the numerator, we have sine 4x plus 4 change in x minus sine 4x. And then here we want to apply sum to product formula. Sum or difference. Now you see that we are having sine minus another sine, right? So this is the difference. So in this place where we have sine x, sine 4x plus 4 change in x minus sine 4x. We said 4x plus 4 change in x, let it be called the letter y. And then sine 4x, let it be called the letter what? Y. Sine 4x plus 4 change in x, let's call it a letter x. And then 4x, let's call it a letter what? Y. Good. Now let's apply it here. Here we have f prime of x is equal to limit as x approaches 0. Now look at it. In these two formula that we brought now, you see that this x, that this sine x minus sine y, this difference is for the first part in the numerator. Is for the what? Is for the first part in the numerator. So instead of writing sine x minus sine y, we can replace it with 2 sine x minus y all over 2 multiplied by cos x plus y all over 2. Okay, good. Now look at it. We are going to have 2 sine. In place of x now, we have 4x plus 4 change in x, then minus y. What is y? Y is 4x all over 2. Then multiply by cos. In this one now, we have x plus y. So what is our x? X is 4x plus 4 change in x. Then we have plus 4y. And then 4y is what? 4x all over 2. That is for the first bracket in the numerator. Now, for the second bracket, here is the sum. Here is the what? Is the sum. Sine x plus sine y. So how do we do it? We have the same 2 sine x plus y all over 2. Where our x is what? 4x plus 4 change in x. Then plus our y is 4x all over 2. Then multiply by cos. This one says x minus y. What is our x? X is 4x plus 4 change in x. Then minus y, which is 4x all over 2. Are we together? Yes. Now let's go. Let's simplify. So, in this case, in the first bracket where we have 2 sine 4x plus 4 change in x minus 4x. Here we have 4x minus 4x. Is going to disappear, right? We are going to have 4 change in x all over 2 remaining. Let's go to the cos. Here we have 4x. Here we have 4x plus 4 change in x plus 4x. So here we have 4x plus 4x, which is 8x plus 4 change in x all over 2. And then the next bracket. Here we have 4x plus 4 change in x plus 4x. It's the same as 8x plus 4 change in x all over 2. Then the second part, cos 4x plus 4 change in x minus 4x. Here we have 4x minus 4x is going to go. So we are going to have 4 change in x all over 2 remaining. Isn't it? Yes. Now let's go. In this case, where we have 2 sine 4 change in x all over 2. And then the second part, we have 8x plus 4 change in x all over 2. Let's factor out 2 in the numerator here. When we factor out 2, we're going to have 2 open bracket 4x plus 2 changing x all over 2. Then the next bracket, factor out 2 again. We have 2 open bracket 4x plus 2 changing x all over 2. Isn't it? And then in this case where we have 4 changing x all over 2. 4 divided by 2, 2. Okay? Yes. So therefore, look at what we have. After clearing the fraction, we have f prime of x is equal to limit as changing x approaches 0, 2 sine 2 changing x multiplied by cos 4x plus 2 changing x, all in bracket, multiplied by the next one, 2 sine 4x plus 2 changing x times cos 2 changing x all over changing x. Hello, are we together? Yes. So in this case now, we are going to split this expression into 2. Okay, we're going to split it into 2 and then take their limit. So splitting it into 2, look at how it's going to be. We are going to have limit as changing x approaches 0. We're going to have 2 sine 2 changing x multiplied by cos 4x plus 2 changing x all over changing x multiplied by 2 sine 4x plus 2 changing x multiplied by cos 2 changing x, all in bracket. All in bracket. So look at this. You see this expression? We can now take the individual what? Limit. So taking the individual limit, we're going to have f prime of x is equal to limit as changing x approaches 0. We have 2 sine 2 changing x multiplied by cos 4x plus 2 changing x all over changing x multiplied by the limit as changing x approaches 0, 2 sine 4s plus 2 changing x multiplied by cos 2 changing x. Hello, are we together? Yes. So when you multiply these two limits or these two expressions, is the same as what we have in the above. Okay? Yes. Now let's go. What do we do again? We're also going to split this first limit into 2 again. We're going to split it into 2. So look at how it's going to look like. We're going to have f prime of x is equal to limit as changing x approaches 0. We want to split it into 2. We're going to have sine 2 changing x all over changing x multiplied by 2 cos 4x plus 2 changing x. All right? Yes. You see it? It's still the same thing. When you multiply it, it will give you the same thing, right? Good. Then we have multiply by limit as changing x approaches 0. 2 sine 4x plus 2 changing x multiplied by cos 2 changing x. Right? Yes. For this first part, let's take the individual limit, right? So taking the individual limit, we're going to have f prime of x is equal to limit as changing x approaches 0 sine 2 changing x all over changing x multiplied by limit as changing x approaches 0 2 cos 4x plus 2 changing x. Okay, good. Multiply by limit as changing x approaches 0 2 sine 4x plus 2 changing x multiplied by cos 2 changing x. Right? Yes. Now let's go. In this case, where we have limit as changing x approaches 0 sine 2 changing x all over changing x. All right, look at it. Here we have limit as changing x approaches 0 sine 2 changing x all over 2. Recall that limit as x approaches 0 sin x all over x is 1. So likewise in this place where we have limit as change in x approaches 0 sin 2 change in x all over change in x is equal to 2. Hello, is equal to what? 2. So here we have limit as change in x approaches 0 sin 2 change in x all over what? Change in x is going to give us 2. Then let's go. We are going to plug in the limits, okay, change in x as it approach 0. Let's go. We have limits as change in x approaches 0, 2 cos. Anyway, we see change in x, we write what? 0. We have cos 4x plus 2. In place of change in x, we write what? 0. Close the bracket. Times the last one here, we have limit as change in x approaches 0, 2 sine 4x plus 2 upper bracket. In place of change in x, we write 0. Then cos 2 0. Are we together? Yes. Now let's go. That means we have f prime of x is equal to, the first one gives us 2 multiplied by, here we have 2 cos 4x plus 2 times 0 is what? Is 0. So here we have 4 plus 0 is 4. So here we have 2 cos 4x. Then that is for the center. Then the last part here, we have 2 sine 4x plus 2 times 0 is 0. Then we have plus 4x plus 0, which is 4x. And then the last part, we have cos 2 times 0 is 0. Cos 0 is what? 1. Here we have 2 multiplied by 2 cos 4x multiplied by 2 sin 4x multiplied by cos 0. I will say that cos 0 is 1. Good. So therefore, here we have f prime of x is equal to 4. When we say 2 times 2, it's going to give you 4 cos 4x multiplied by 2 sin 4x, right? So when we say 4 times 2, it's going to give you 8. So therefore, we have f prime of x is equal to 8 cos 4x sin 4x. So therefore, the derivative of y is equal to sin squared 4x is equal to 8 cos 4x sin 4x. We just found this using the first principle or by definition. It's very simple. Please, I want you to watch this over and over again for you to get a concept, and you should be able to solve similar problems like this. All right? Yes, please don't be in a haste. Just calm down, watch them over and over again. I'm very sure you will get to understand it better. Thank you very much for watching. Please, if you are new to our YouTube channel, if today is your first time, please do well to subscribe if you have not, like and share our videos, and stay blessed. Thank you.